Equilibrium. Equilibrium is one of the chapter where you feel it is difficult, but to be honest, it's just key. Most of time we give the least priority to this. That's why we will solve maximum number of questions from this chapter compared to any other. Like हेलो, एक वो बात नहीं हो रही मेरे हिसाब से स्टूडेंट खाना खाने जा रही है तो बात होने दे, मैं तेरे तरफ फोन करूँ. ठीक है. ठीक है. ठीक. Okay. So equilibrium, but this equilibrium is ionic. So we know about equilibrium condition where forward reaction is equal to backward reaction. But this time ions are involved. That's why this is ionic equilibrium. Equilibrium in which ions are involved. Correct? So there are multiple property of this ionic equilibrium. One of the common property is that here you have reversible reaction because equilibrium, reversible reaction. Mm, reversible reaction. Second, you know equilibrium always occur in the closed container. So this occur in closed container. Correct. And third, this is applied to the weak electrolyte. Because in strong electrolyte there will be 100% dissociation. Correct. In strong electrolyte there is 100% dissociation. Okay. So these are the basic features of equilibrium. In general, ionic only last point is related with the ionic equilibrium. 1 minute. One minute. Ah, so when we say any kind of substance, there are different type of substance: conductor, insulate. Correct? Insulate. In case of conductor, there are two type of conductor: metallic conductor and ionic conductor. I will talk about ionic conductor here. Correct? Because in case of metallic conductor, there is a current due to the movement of electron, and we know about this thing. But ionic conductor is something that we relate in the ion, in the electrolyte condition. So we know here we have ion. Because of this ion, when these ion move, they will cause current, and ion will move toward the opposite electron. Correct? And because of the movement of the ion, there will be current. Next is the electrolyte. Jordan, what is electrolyte? When you pass current through any substance and this passage of current will lead to the breakdown into different ions. So then it is light. In presence of electricity, there is a formation of ion. Correct? Ion formation in presence of current. Electrolytic cell. So current will break down a molecule into the ion. You know you have two type of electrolyte, strong and weak electrolyte. In case of strong electrolyte, there will be 100% dissociation, complete ionization in the ionic condition, uh, complete ionization or complete breakdown in solution, in aqueous solution. In aqueous solution, and all the molecule will convert into the proper ion. Correct. In this case, if you see degree of dissociation, alpha is degree of dissociation, it will be 1, or simply we are saying 100% dissociation. That's why it is a strong electrolyte. Correct. Second electrolyte is weak electrolyte. Weak electrolyte. In case of weak electrolyte, 100% ionization is not possible. That's why it is weak. So your alpha value will be less than 1, or dissociation you will say will be less than 100%. Correct. So in this case, if you see, there are two type of weak electrolyte: weak acid, weak base. Correct. There will be weak acid and weak base. Both can be weak. And in this chapter, we
Sir,
will
in
talk
strong
about only weak
electrolyte,
electrolyte.
is there no weak acid? I mean, acid and base.
In strong electrolyte, we don't have weak acid and base.
No, in strong electrolyte, don't we have acid and base?
Yes, we have. Let me
Okay.
write this example as well. So in case of strong electrolyte, you have same way strong acid and strong base. I need to write example of this. So example of strong acid, is H2SO4 because easily break down into ion. You have HCl strong acid. You have nitric acid strong acid. You have HClO4 strong acid. You have HBr strong acid. HI. Why I'm not writing HF? Breakdown is difficult. Right? There is a strong bond,
Sir, in
right?
what?
And many more.
HS.
HF. HF.
HF. Okay.
So there is a strong association. So breakdown into iron is difficult, but iodine is easily released. Correct. Same way you
So
have
HS is what?
HF uh, can produce H positive ion, but at the same time there will be strong hydrogen bonding. So ion formation is difficult because of the strong intermolecular hydrogen bonding in HF.
Okay.
Correct. In case of strong base, alkali metal base are strong base KOH, NaOH, or cesium OH, or rubidium OH, or group second like barium hydroxide, calcium hydroxide, all this. So group 1 and group 2 element are usually strong base. Correct. Group 1 and group 2 element are strong base. Why we are not writing lithium? Answer is down the group reactivity increase. So cesium will be most reactive, based on the reactivity. So they can easily form this ion. But lithium is little bit covalent in nature. Here we are talking about ions. So we want maximum ionic bond, right? We want maximum ionic bond. And last, You can have salt also, like NaCl, salt, KCl, copper sulfate, and many more. So nobody going to ask you all these questions, but it will help you in the many things. Example, in organic, when we are talking about ki we need strong acid, strong base. So at least you will get some idea. Ki which example, when we write base in case of aldol condensation. So you can write any of these base, right? Sometimes you write KOH, sometimes you write NaOH, sometimes you write barium hydroxide. So all these are the strong base. We need strong base. Correct. Come to the weak electrolyte, because this chapter particularly is about the weak electrolyte. I already mentioned here. This chapter is mainly for the weak electrolyte. So in the weak acid, you can have multiple acid like HCN, CH3COH, very popular. CH3COH is one that you will use again and again. HCOOH, carbonic acid, weak acid, right? H2PO3, hypophosphoric acid, H3PO2, or H3BO3. All these are the weak acid. Last year we did S block and P block. In there we did key H3BO3 is weak acid. Correct. Same way you have weak base in the buffer solution. All these will matter a lot when we'll discuss about this. Ammonium hydroxide is weak base. Copper hydroxide, weak base. Zinc hydroxide, weak base. No need to remember all these things. The
Sir,
more
what's
you
the
will,
last acid?
H3BO3, H3BO3, boric acid. So don't memorize all these examples. I'm not asking you to memorize all these examples. Just the
Sir, it's
more example,
hydroboric acid or boric acid. Is it the same?
yeah,
Okay.
or aluminum hydroxide. So what I am trying to convey, not telling you to memorize all these examples, but the more example you see, you start doing like correlation. See how I can relate all these concepts together. Correct. Now, if you are done with it, we are coming to the main
So one
part.
second, can you scroll back up?
Yeah.
Done, sir.
Hmm. So very popular concept of Arrhenius. Based on the Arrhenius, you can tell whether a compound is acid or base. So first is Arrhenius concept. In this Arrhenius concept, electrolyte will dissolve in water and electrolyte will form cation and anion. You know that. Correct? Amount of cation and anion will be same. Example CH3COH breakdown. So what will happen? This is neutral. It will break down into CH3COO negative and H positive. Remember, whenever you will write any reaction in this case, you will always draw equilibrium. Equilibrium is one of the basic concept here. Ki ionic equilibrium is applicable only in the equilibrium situation, as name suggests, right? So this is weak acid. If you see number of ion, positive ion and negative ion are exactly same. So in this case, you will say that this solution is electrically neutral. Electrically neutral. It means cation and anion will be exactly same. cation and anion will be exactly same. And all the property of any solution is decided by the ions. Ion will decide the color. Example, if you take copper sulfate, we discussed this in the uh, coordination compound in crystal field theory. कि copper sulfate, if uh, you take dry form, then it is colorless. But if you take copper sulfate solution, it will be blue color. We did it there in coordination compound. If you don't have any water, there will be no color. But if you add water in this, there will be a color. So what is the reason for this blue color? Copper ion. What is the reason for this blue color? Copper ion. That's what we are saying. The iron are responsible for color. Correct? Iron are responsible for this color. And in this situation, cation, which is positive charge, will try to move toward the cathode. Remember, in the whole this thing, we have electrolytic cell. So, Anvita, if you consider electrolytic cell in this chapter,
Hmm.
because electrolytic system, what is the charge on cathode and anode?
Anode is positive, paper is negative, right?
Yes, anode is positive, cathode is negative. If we see in this situation, cation which is positive will move toward the cathode and anion will move toward the anode. Make sense? Correct. So whenever we have any kind of ionic equilibrium, example you have AB like CH3COH in the aqueous solution, what will happen? There will be equilibrium system and you will have positive ion and negative ion. But 100% breakdown will not happen and reaction should be reversible. In this case, if you see ionization constant K, Pratikya, what will be the value of ionization potential constant K? Equilibrium constant or ionization constant?
Product by reactant.
Pratikya,
Product divided by reactant.
product divided by reactant. So our products are A positive and B negative, and our reactant is AB. Correct? This is equilibrium constant or ionization constant. Correct? Any doubt? Any doubt, guys? So next question, Chandana. Is H2SO4 is strong acid in aqueous solution? Chandana, is H2SO4 a strong acid or not in aqueous solution?
No, sir.
Yes, it is strong acid in aqueous solution. In general, H2SO4 is a strong acid, right? Strong. Okay. Do you think, Chandana, H2SO will completely ionize in the aqueous solution?
No, sir.
Why we said H2SO4 is a strong acid? Because it completely ionizes. Weak acid will not 100% ionize. Make sense? Any doubt? Any doubts, Sandana?
So I'm sorry, sir. The network's really bad.
It's okay, Jordan. Sandana, any doubt?
No, sir.
Ah. So, if you don't have any doubt in this case, before going to the Ostwald dilution law, this is very popular, Ostwald dilution law, we will simply compare all the acid and base in different way. Acids and base. Okay. So, first, normally, acid will give H positive ion in water, release H positive ion in water, and base give OH negative ion in water. Okay? And this concept is known as Arrhenius concept. If any chemical release H positive ion is acid, and chemical that release OH negative ion is base, that is the bare minimum thing we have studied in the last class. Correct? Second is based on the taste. What is the taste of the acid and base? Acid are sour in taste and base are bitter in taste. Base bitter. Correct. Third, you have litmus test. Litmus test. In case of acid, blue color will convert into red, and in case of base, red will convert into blue. Okay. So the simplest concept as you can compare here is that base bitter, base blue. Base bitter, base blue. Next. Charge like this, na? Charge. Hmm. Next. If you see the pH, Jordan, what will be the pH in case of acid?
So it will be 1 to 7. Also, or
Yes.
like below 7. Huh.
pH will be below 7 in case of acid, and in base, pH will be more than 7. Any doubt?
Yes, sir. No doubt.
Uh, Tanvi, what is the Bronsted-Lowry concept?
So what?
Bronsted-Lowry concept.
Not sure, sir.
Okay. So, next fifth, we are comparing acid and base based on the Bronsted-Lowry concept. Bronsted-Lowry concept. First concept was Arrhenius, very important. Second concept is Bronsted-Lowry. Based on the Bronsted-Lowry, they said if any chemical give H positive ion in any medium, then it will be proton donor and acid. Acid is proton donor, and if it is a proton donor, give give H positive ion in any medium. Okay. If you see base, if you define, it will be proton acceptor because opposite to the acid, and base will accept H positive ion, like ammonia. Ammonia is a base not because ammonia release OH negative ion, but because ammonia accept as positive ion and become ammonium ion. Make sense, guys? Any doubt?
No doubt, sir. Sir, can I go wash my face and come?
Yeah. Last is the Lewis concept. Lewis concept says that ki acid is simply the chemical that is electron acceptor. Electron acceptor is acid and base are electron donor. Correct? So you have three concepts. First, Arrhenius. Give H positive ion acid. Give OH negative ion base. Second, Bronsted. Give H positive ion acid in any medium. Accept H positive ion base. Or proton donor acid. Proton acceptor base. And opposite to proton, you have electron. Opposite to proton, you have electron. If anything, donate proton. So it will accept electron. Meaning it's correct. So these are the three very popular, very important points. Any doubt, guys, in this? Any doubt?
No, sir.
If you don't have any doubt,
Yes,
can
sir.
we say yes, Pratigya?
सर बेस एसिड H प्लस ये भी मतलब एनी मीडियम में होगा
Base?
एसिड H प्लस
हाँ.
मतलब ये भी जो कोई मीडियम में भी एसिड कर सकता है ना
प्रतिज्ञा तुम्हारी आवाज तो साफ आ रही है बट मैं कुछ शब्द को सही से सुन नहीं पा रहा हूँ तो जिसकी वजह से दोबारा बोल सकती हो
सर जैसे कि आप लिखे हैं एसिड गिव H प्लस इन एनी मीडियम वैसे मतलब
हाँ
बेस भी एक्सेप्ट H प्लस एनी मीडियम हो सकता है कि या फिर
बिल्कुल
कुछ
करेक्ट
पर्टिकुलर होगा सर
ये हो सकता है कि एक्सेप्ट एज पॉजिटिव इन एनी मीडियम बिकॉज एक्वस के लिए तो आर्हीनियस का कॉन्सेप्ट था ना अगर पानी में ही बात होती तो इसके लिए तो वाटर था करेक्ट तो इसके बेस पे हम ये बोल सकते हैं कि जितने भी आर्हीनियस एसिड हैं वो ब्रोंस्टेड एसिड तो होते ही हैं जितने भी आर्हीनियस एसिड हैं वो ब्रोंस्टेड एसिड तो होते ही हैं क्योंकि ब्रोंस्टेड में कोई भी मीडियम में एच पॉजिटिव दे दें एंड इन केस ऑफ आर्हीनियस give as positive only in water correct so in arrhenius only in water and in bronzed in any medium so any medium is umbrella term within this umbrella term we have aqueous solution so that's why you can say and this question can be very popular all arrhenius acids are bronzed acid bronzed laurie acid correct same way all bronzed base or bronzed base because bronzed base accept as positive ion in any medium or it donate electron to any medium so all are electron donor it means Lewis base without very important both the two all all arrhenius acid bronzed acid all bronzed base Lewis next You know, hello, हाँ रवि, लाइन में दोबारा एक बार फाइनल कॉल कर दो। हाँ मेरे हिसाब से कोई लाइब्रेरी में स्टडी कर दी होगी तो ज्यादा दिक्कत है। ठीक है, ओके।
So can you
मेरे को
scroll
कॉपी
a
कर देते,
little bit up?
इसमें पढ़ देगा। हाँ यस,
We have some more than enough. Just that last Lewis concept part. I just want to write that.
ओके। रेडियस, रेडियस आर अल्फा ना, आर रेडियस, वी आर ओमेगा आर रेडियस। Jordan,
Yes, sir.
do you have any other number of Sarah, or can you
I
call
have
her
a
phone?
mother's number. Do you want me to call?
Yeah,
I'll call her mother, no?
yeah. So
But what
tell
do
her
I ask her
ki,
mother, sir?
like Deepak sir arranged math class for her exam, board exam.
Huh.
And I discussed with the sir. He said ki 4-5 chapter he can do today, 4-5 chapter tomorrow by
Hmm.
afternoon, so she can revise properly.
Okay, sir. I'll
So,
speak.
but I think she must be in the library, maybe. That's why.
Maybe I'll have to check if she's in hostel or she's at home. So that's like the other thing.
Okay,
I'll just call auntie
call her
once
mother.
and I'll ask
Yeah,
her.
sure. So, guys, whenever we say ki anything like this, you have acid and acid give as positive. This as positive will dissolve in water and it will become H3O positive. So H positive or H3O positive is the same thing. Means acid dissolved in the water. Correct? Got it? Next, if you see acid, we know acid will release H positive ion whether in water or any other medium. So what will happen if you have Ha? A means acid. So it will break down into H positive and A negative. Correct? So acid will give conjugated base. Acid will give conjugated base. And when base accept H positive ion, it will form conjugated acid. Okay. So acid form conjugated base or base form conjugated acid. It can also form like this. Like if a base react with any OH, it convert into B positive and OH negative. So this is again conjugated acid. Okay. So acid form conjugated base, base form conjugated acid. Any doubt, guys?
No doubt.
Acid form conjugated base and base form conjugated acid. Example: If you take two water molecule H2O react with another H2O and it convert into, because we are talking about equilibrium, H3O positive and OH negative. Example, let's take this is acid, this is base. You can take randomly anything, doesn't matter. So acid, what will happen? Base will accept as positive ion. So this will be conjugated acid. Base will form conjugated acid. Correct? Acid will release as positive ion and remaining thing is OH negative. So this is conjugated base. Any doubt, guys? Same thing. Okay. So based on this, you can say कि weak acid will have strong conjugated base. If acid is weak, so base will be strong, as simple as that. So weak acid will have strong conjugated base. Same way, like weak base will have strong conjugated acid. Right? How? Example, if you have weak acid CH3COOH equilibrium, it will convert into CH3CO negative and H positive. We know this is acid and this one is weak acid. So it will form very strong conjugated base. How do we know? After releasing as positive ion, it want to accept as positive ion at any cost. So if anything accept as positive ion is base, strong base, correct? Same way, if you have strong acid will have weak conjugated base. Weak acid will have strong conjugated base and reciprocal. Got it? Any doubt, guys, in this?
MLT minus 1 force side diamond control.
MLT minus linear momentum.
Force
MLT minus 2. Shit. Any doubt, guys?
No, sir.
One more thing we can add in this notes, Lewis concept. In Lewis concept, acid accepts electron. In case of acid, Lewis acid, it accepts the electron. If it accepts electron, it means it should have vacant orbital to accept electron, correct? So that's why you will say, in case of acid, you will have vacant orbital to accept this. You will have vacant orbital. And in this case, it will be incomplete octet. AlCl3 is acid. How do we know? Aluminium have 3 valence electron. Chlorine will share 3 electron. Total number of electrons 6. But for octet we need 8. So we have shortage of electron. Correct? We have shortage of electron. So it will be electron acceptor. Example, AlCl3 or group 13 element, or BeCl2. B have 2 electron, 2 Cl. So total 4 electron. You still have shortage of electron. Correct? So in case of acid, you will have vacant orbital and there will be incomplete octet. As you can see in AlCl3, it is acid. How do you know it is acid? Because 6 electron in out total. BeCl2 total 4. But if you take base, in case of base, you have complete octet. And here mostly it is present with the lone pair. Example, NH3, ammonia. If you see this ammonia have complete octet because nitrogen have total 5 electron in outermost shell, 3 from the hydrogen, total 8 complete octet. And this have lone pair here. So it is base. It is electron donor. Because it have extra lone pair, only then it can donate lone pair. Make sense? Any doubt, guys?
No doubt, sir. Just 1 second, I'll copy.
Tell me, as of now, is it too difficult to understand?
No, sir.
Ah, done?
Yes, sir. Done, sir.
Now we are having most popular topic of this chapter, and you will 100% get
Sir,
question
1 second
from.
before that, can you just scroll up a little bit?
Yeah,
Weak acid. I just want to copy the weak acid become strong base example. Done, so you can.
so we are going to read most important topic of this chapter, and you will 100% get this question. The very first question in ionic equilibrium is based on this only. Ostwald dilution law. Most popular topic of this chapter. Ostwald dilution law. In this Ostwald dilution law, you apply law of mass action to ionic equilibrium. We apply law of mass action, what we studied in the last chapter. Equilibrium constant, product by reactant, that part. Correct. Second, it is applicable only for weak electrolyte. Because everything in this chapter is applicable only to the weak electrolyte. Correct. Third thing, if you have weak electrolyte solution, if you have weak electrolyte solution and you do dilution, because of the dilution, degree of dissociation or ionization will increase. Degree of dissociation, or same thing we call it as ionization, degree of ionization will increase. And if degree of ionization increase, there will be more current. Same concept is given in your electrochemistry, molar conductivity for concentrated solution and for the dilution. So whenever you do
Or
dilution, yeah, Jordan,
I somehow managed to get Sarah on the line. She'll call you another 2-3 minutes.
what happened to Sarah?
Sir, full confusion in family. I had to call some five, six uncles to figure out Sarah's position, and then I got her online. She's at some cousin's house who has chicken pox. I told her to get out of that house now only because if she gets chicken pox, the gone case then. She'll call
So,
you now, sir. Her maths exam is tomorrow, it seems.
she told me day after.
Sir, it's tomorrow. That's what she told on call. I called her. She like, nah, she said it's for tomorrow. And I told, call sir right now. Call sir right now.
Hmm.
Something and all, sir. Our family's full chaos, sir. I had to call some five, six aunties, uncles just to figure out where she is. And they're all giving me advice and not her.
She's giving you advice for
Not
NEET.
she, sir. These uncles, aunties. Like, I called one of
Yeah.
my uncles. He's
Yeah,
also
I would have like your relative are giving you advice for what?
for neat and all, like one of my uncle Rajan Papa was like, oh, this time you have to study, have to get it. I will pray for you and all that. This year, I'm very sure you'll get it. Full support he was giving. Some other auntie was like, we will not disturb you. Don't call. Also, you study after May. You can call us and all. Don't take tension. All we're with you. We'll keep prayers and all. Other aunties
Hmm.
like, oh, you should study, Jody. Your parents are telling your marks are, oh, okay, okay, and all that. You should study more, become like this cousin of mine and all that. Very funny drama. They're all different language. I'm getting these bhashans, sir. I was like very tired.
Okay.
So now I
No.
found her location. She said she'll call you. I gave her one
Is
dose.
she in hostel or house?
She's in house, apartment. So
Okay.
three of my dad's brothers stay in one apartment. So she
Okay.
keeps rotating between the houses there.
Hmm.
So one phone call to her house, her dad picked up. Then dad was like, she's in the apartment. Then I called my cousin who's in the apartment. He's in Bangalore. He's like, call my house. So I called that house. That uncle's like, you have to go call this other auntie's house because she's probably there. After that, I called. She's like, that auntie's outside doing shopping. So she's like, call my cousin. I call cousin. Dad picks up, and then he also gives Basha, and then she finally get to Sarah.
Wow, man, tell me what you missed from this topic.
So I have to scroll up lots.
See, this one.
A bit more. I've been from the network loss also missed quite a lot, sir, in the beginning. Bit more. There I finished acids, bases, and also till Lewis also I finished, and everything else was just not there in a meeting or with
Take
Sarah's
screenshot of
call.
this.
Yes, so 1 minute. Yes, sir, took it.
Now I'll tell you Ostwald dilution law because this is important
Yes,
and
sir.
you are doing important job. Ostwald dilution law is most popular topic of this chapter. In this topic, we apply law of mass action, what we have studied in the last chapter. Okay. This Ostwald dilution law is applied only to the weak electrolyte. Not only this, like whatever topic we are reading in any equilibrium is applied to the weak electrolyte only. Okay. And in general, whenever you increase dilution, like in electrochemistry, you have studied that whenever you increase dilution, conductivity will increase, right? On dilution, conductivity will be increased because there will be free movement of the ions. Same thing here. Okay? Whenever you have weak electrolyte and you do dilution, degree of dissociation, which is also symbolized by alpha, will increase. There will be more dissociation. And at infinite dilution, you will see almost 100% ionization. So alpha will be almost approximately 1. Okay, almost 100% dissociation. Any doubt?
No, sir.
Huh. So because we will apply law of mass action, so let's take one example. You have A, B, any weak electrolyte. So this will break down into A positive ion and B negative ion. Okay. Let's see at time 0, concentration of this is C and these two are 0 because no product formed yet. At equilibrium, this is initial condition. At equilibrium, if we see then some of the product will form with some degree of dissociation. So let's say this is C alpha, this is C alpha. So it will be C minus C alpha. Any doubt, guys? Anybody? It is almost like same thing you did in the chemical kinetic. First order reaction at T0, there is no product, but after some time, some product will form. Do you remember? Any doubt? Same
No.
equation is given in your want of factor of uh, a solution also. And I do remember I need to explain this want of factor topic once again. But before that, I wanted to explain this. Correct. So this is extremely important. At after some time, you will form some product and reactant will reduce. Correct. Reactant will reduce. If you apply law of mass action, so you know equilibrium constant K will be equal to A positive ion, B negative ion divided by AB. Correct. So what is A positive ion? C alpha multiply with what is B negative ion? C alpha divide by, and this what is this? C minus C alpha. Correct. So this is C square alpha square divide by, if you take C common, 1 minus alpha. C cancel. Correct. So your equilibrium constant is equal to C alpha square 1 minus alpha. Very popular. Extremely popular. This is the real formula, and very first question is based on of equilibrium constant. Okay. But but if if alpha is very less than one, like you know dilution is less, breakdown is not proper, then you will see 1 minus alpha is approximately equal to 1. In that case, K will be equal to C alpha square, correct? Or alpha square will be equal to K by C, or alpha will be equal to under root K by C, correct? Remember, this is applied when degree of dissociation is very less than 5%, less than 5%, or alpha value is less than 0.05, when degree of dissociation is very less. So we will consider that there is no dissociation. Correct? We will consider there is no dissociation. Correct? Any doubt? So in this case, you can ultimately say your alpha is inversely proportional to under root C concentration, because K is fixed for given temperature. It means if you increase concentration, alpha will decrease. If you increase concentration, degree of dissociation will decrease. If you decrease concentration, it means more dilution. If there is more dilution, then alpha will increase. And I told you earlier, ki if you do dilution, then alpha will increase. Any doubt, guys? Any doubt? Ostwald dilution law tell you this is applied to the weak electrolyte. In this case, your final formula equilibrium constant is C alpha square minus 1 alpha. This is the real formula. But if degree of dissociation is very less, 5% I is what Sarah scored. Hello, Sarah. Hello, Sarah. It's okay. Are you okay? You are stressed? When is your exam? Tomorrow or day after? Day after tomorrow. Good. So I discussed with sir, and he said yeah, I have sent link. I had discussion with him, but he had an emergency work, so that's why uh, he will take class now. But he said he is good in it, and he can make sure your syllabus will be over by tomorrow, by afternoon. So you can revise the important topic, important question. So don't worry about this. Okay, I'll call him once again, so he's ready for the new link, and I'll send you link. Okay. Yeah. So once you finish your dinner, text me, then I'll call him. Okay. Okay. So guys, what we are understanding in this case, more dilution, more alpha. So can we say through this your alpha is directly proportional to the dilution? More dilution, more degree of dissociation. You get this kind of question. What is the impact of the dilution? Degree of dissociation, increase conductivity, increase. That's what given in your electrochemistry part. Correct? And at infinite dilution, what will be your degree of dissociation? Almost 100%. Correct? And out. So if anybody asks, what is Ostwald dilution law? It's simple. Ostwald was the guy who said if you dilute any electrolyte, weak electrolyte, then your ionization increase with dilution and ionization decrease with the concentration. That is what Ostwald dilution was. This is dilution. On dilution, degree of dissociation increase, and on increasing concentration, degree of dissociation decrease. Yeah, any doubt? Any doubt, guys? So most of time, so if you get easy question, your formula will be K is equal to C alpha square. But what I have seen in the recent time, it was this formula based, original formula. Okay, this formula is really, really, really important, along with the what is the impact of dilution and concentration. Okay. Now application, because the real question asked from the application part, what happen if you have mono basic weak acid? And what is the meaning of mono basic weak acid? It means it release one H positive ion. We are talking about application part. So mono basic weak acid, because this law is applicable only for the weak electrolyte. So we have weak acid. Mono basic, it means one H positive ion. It's like any acid one with. So what will be the rule in this case? Everything is same what we did. So you will simply write in this case equilibrium constant for Ka will be equal to C alpha square 1 minus I will not teach anything. Okay. So this is your thing. If you see alpha, alpha will be equal to under root K by C AA for acid. Correct? Any doubt, guys? Any doubt in this? Also, if you take this HA, then it will break down into H positive ion and A negative ion. Initial concentration C 0 0. Final concentration C alpha, C alpha. This is C minus C alpha, same thing. Okay. If you see your H positive concentration value, this is equal to C alpha. Correct? C. What is your alpha value? Under root K A by C. Correct? So, can we say in this situation your H positive ion concentration will be equal to, it will go inside under root Ka multiplied by C. C is concentration. Tell me guys, whatever we did is just replication of your Poisson division. Force into displacement cos theta angle have DDC. So work done is equal to Fs cos theta. Any doubt, guys? Right. And if you don't have any doubt in this situation, then you know your pH is equal to minus log as positive concentration. Correct? If we put as positive value, then our pH will be equal to minus log, and as positive value is under root Ka multiply by C. Correct? You know power will come into the multiplication. You can remove this under root, and instead you can write 1 by 2. Under root is equal to power 1 by 2. Power will come into the multiply minus 1 by 2 log Ka plus log C. Why is like that? Because log A into B is equal to log A plus log B. We are applying same thing. Log Ka minus no.
So can you scroll up?
So this is important. Yeah. Okay. And if you do this, then I will write the same thing. In this situation, pH is equal to minus log Ka is equal to pKa. So this will be equal to 1 by 2 pKa minus 1 by 2 log C is common. So I proved that how you got this. So in the same situation, your pH value is equal to 1 by 2 pKa minus 1 by 2 log C. Very, very, very important. Okay, very, very, very important. Because K is equal to C alpha square by 1 minus alpha is same thing. Alpha is equal to under root K by C, same thing. We wrote this H positive is equal to this by using this formula because H positive is equal to this. And we wrote pH by using normal simple formula pH. How to calculate pH? Minus log H positive. Put H positive value, get the value, and you got the final answer. Correct? Very, very, very important. If you want to calculate pH and pKa is given, you can calculate this. Concentration and pK given, you can calculate. Or pH given, pKa given, you can calculate C value. Correct? This is for monobasic weak acid. For monoacidic weak base, you can calculate exactly in the same way. So I will not repeat. Are you done with this, guys?
No, sir. Can you just give 2 minutes to write?
Sure. Second part is just copy paste of this.
So till when will you take class?
आज तो मैं बहुत ज्यादा लूंगा क्योंकि ये तो करना जरूरी है ही Ostwald dilution law.
तो कब तक मतलब मैक्सिमम?
The maximum, there is no limit.
Sir, I'm writing it, but can you explain this again?
Which part, Tanvi?
Sir, just briefly, can you explain the whole thing? Brief is enough, sir.
And from the starting.
हाँ sir, for monobasic acid.
So monobasic acid,
Weak
when acid break down, it will release into H positive, release H positive ion and your conjugated base, right? So initial
Yes, sir.
concentration is zero, zero for the product and maximum for the reactor.
Okay, sir.
Correct?
Yes,
If
sir.
this is the situation, what will be H positive concentration? C alpha.
Yes, sir.
C remains same. Alpha value is under root Ka by C. Why we are writing Ka? Ka means equilibrium constant for acid.
Okay, sir.
Now you want to calculate pH and pH value is equal to minus log H positive. Log same as what is the H positive value? Under root Ka multiply by C whole 1 by 2 because instead of under root we are writing 1 by 2. Why?
Yes,
Because your H positive is equal to this under root Ka
yes, sir.
multiplied. So 1 by 2 will come into multiply log Ka plus log C in the bracket. We know, and what is the reason for this? Log A into B is equal to log A plus log B. Okay. So minus log Ka is equal to pKa. I will write this part out. Minus log Ka is equal to pKa. Same way, minus log Kb will be equal to pKb. It is same like H positive ion. Minus log H positive ion will be equal to pH. So every time you are adding P in front of everything, correct? Minus log and you are converting into this. Any doubt?
No,
General.
sir.
So through this you got the formula pH is equal to minus 1 by 2 pA minus log C. 1 by 2 log C. Any doubt?
No doubt, sir. I'm almost done writing. 1 second.
Anvita, I think I'll give break for 10 minutes after this topic and then probably 11:30 will I'll take class.
So could you repeat? I couldn't hear you.
Now, I'll give break after this. One more topic based, week based, for 10 minutes.
So it's okay
Probably
to stop like
maximum 11:30. Maximum, I'll try to wind up by 11. But maximum is 11:30.
okay. I would say if you like don't give break. Like I would say that I don't know about others, but like I think if you'll give break, I'll sleep off.
10-minute break, so I will have dinner. That's
अच्छा,
fine.
okay. हाँ.
Yeah. Done, guys, everybody. Monoacidic weak base. It means you have BOH. Base because it will release OH negative ion. Correct. So what happened in this case? Everything is exactly same. Same. It was how? Because your BOH will break down into B positive and OH negative. Initial concentration C00. After some time at equilibrium, this will be C alpha, this will be C alpha, this will be C minus C alpha. Correct? What will be OH negative concentration is equal to C alpha. Correct? All other rule are same. Kb will be equal to C alpha square 1 minus alpha. Correct? Next, if you see this, you got Kb, your alpha value will be equal to under root Kb by C. In case of acid, it was Ka. In case of base, it is Kb. Right? In acid, it is Ka. In base, it is Kb. Everything is exactly same what you did in case of acid. Okay? So, if you write here in C and instead of alpha, you will write Kb divided by C. So, ultimately, your OH concentration will be equal to under root Kb multiply with C. In acid, it was Ka multiply with C, and here it is Kb multiply with C. And out, everything is copy paste. Copy paste. See, upper one. I need to charge tab also. Good, we can take break. So, this part is done, like your base. And same way, if you calculate your POH, your POH is minus log OH negative concentration. Okay. So POH is equal to minus log what is OH negative concentration? Kb multiply by C whole power 1 by 2 because under root. Same multiplication POH is equal to minus 1 by 2 log Kb plus log Kc. Oh, sorry, C, not Kc. Log C. Correct? Minus log Kb is equal to Pkb and this is equal to 1 by 2 log C. और अभी बेसिक क्लास में आया था पता No. क्लास में आ जाता है, नीट एग्जाम पास में आ गया नहीं। हाँ, मृदुल क्लास में जाते हैं। हम्म। तेरे लिए भी, हाँ मैं क्लास में हूँ, तेरा खतर भी अपडेट है कि वो क्लास हो जाएगी, वो बच्चा पढ़े हैं और हाँ ठीक है, कुछ ले लिए, स्टार्ट कर लिए, इतना भी उसका एग्जाम डे आफ्टर टुमारो है, तो प्लान करिए थोड़ा सा जल्दी करने की ताकि रिवीजन कर टेबल और करने दे रहे तो मास्टर इस चीज का। ठीक है। ठीक। हाँ, यह बात सॉरी कंफ्यूज हुई है। हाँ तो लेकिन बस मेरी बात हुई थी 10 मिनट पहले ना, वो डिनर लेने लग रही है, तो फिर लगभग 10-15 मिनट में रेडी है लग जाएगा, तो बाहर बाहर है गए। बस ठीक है, अगर आप तैयार हो क्लास पेमेंट के लिए। ओके, so guys tell me, did you get anything new from this, or is it exactly same what you did in the week asset? Copy paste same. Instead of KA, you are writing KB, nothing else. Right? It's just for revision, we are writing everything again and again.
So does it break now?
Uh, okay, let's take break.
No, I'm just
After
asking, sir.
no, I'll give break because after that I'll solve 3-4 questions
Yes,
on
sir.
this
So
topic.
can I go put my clothes on the
Yeah,
line?
sure.
Yes, sir. Thank you, sir.
Yeah, okay.
Sir, I'll also
Okay.
come back in 10 minutes.
Yeah. So I'll start at 10:45. So, as positive C alpha OH negative C alpha, so it will be equal to C into K under root. In case of acid, it will be Ka. In case of base, it will be Kb. Everything else will be same. Correct? You know pH is equal to minus log H positive as positive concentration. POH is equal to minus log OH negative concentration. Correct? Method is same. And if you overall calculate it, it is 1 by 2 pKa minus 1 by 2 log C. Same here, POH is equal to 1 by 2 pKb minus 1 by 2 log C. Correct? Any doubt? As I mentioned, this is only for the practice.
Sir,
I
I'll
will.
come back in 2 minutes.
Okay, Tanvi. So, if you understood this well, solve this question. Mm,
So solve which question?
I am writing question.
Oh.
Question number 1. Find the value of alpha for 10 raised to power minus 4 molar of HCN solution if H positive concentration is equal to 10 raised to power minus 5. Any doubt? H positive is equal to C alpha. This is the formula. Put H positive value, put the C concentration value, and then you will get alpha. Got it? Next
Yes, sir.
question. If you have 10 molar of CH3COOH, then if your Ka value is 10 raised to power minus 5, calculate alpha, H positive concentration, and pH. Tell me guys, any doubt? Ka is equal to C alpha square. You can calculate alpha value, this. H positive is equal to C alpha, this. pH minus log H positive.
Sir,
Yes, Pratigya.
alpha is 10 to the power minus 2, no?
Alpha is equal to 10 raised to power minus
No, sir,
2.
no, sir. No, sir, got it, support.
So, next. We did.
Sir,
Yes, Pratigya.
there is also formula of root over Ka into C, H plus equal to.
तो पूछना क्या चाहते हो, क्वेश्चन क्या है इसमें?
सर हाँ के वैल्यू भी दिया है एंड कंसंट्रेशन भी दिया है, तो वैसे भी हो सकता है ना, Ka into C.
नहीं, Ka is equal to C alpha square divided by 1 minus alpha, यही बोल रही हो?
नहीं, आप एक फॉर्मूला भी लिखते हैं, H plus concentration equal to Ka into C.
कौन सा फॉर्मूला?
वो जो नीचे वाला सेकंड वाला है,
OH negative ion is equal to Kb into C,
हाँ
like
वो भी
same.
H plus में भी वो देखिए ना,
हाँ, ऐसे भी निकाल सकते हैं.
ये वैसे मेरा तो 10 to power minus 2 है.
देख लेते हैं Ka की वैल्यू कितनी है. यहाँ H positive concentration under root Ka 10 raised to power minus 5 and C 10, so it will be 10 raised to power minus 4, under root will be 10 raised to power minus 2. यही तो आया है, यहाँ पे भी यही था, है ना?
ओके सर.
हाँ. तो नेक्स्ट है फैक्टर अफेक्टिंग अल्फा. फैक्टर अफेक्टिंग अल्फा डिग्री ऑफ डिसोसिएशन.
Sorry, sir, I'm back. Can you just show the above part? I'll just take screenshot.
Yes, we did this.
Question, sir.
question.
Okay. Yes, sir. I'll do it. I'll do it next break or something.
Yes. So, first factor is temperature. If you increase temperature, you know degree of dissociation will be more breakdown. Correct? Why? Because this process is endothermic process. And when you increase temperature, heat will increase. Heat increase means more dissociation. Second factor is dilution. We already did this. If you do dilution, then alpha will increase. Why? Because alpha inversely proportional to under root C or directly proportional to under root V, volume. Okay, volume. Correct? It also depend upon the nature of electrolyte. Example, in case of one, two, in case of strong electrolyte, you know alpha value will be equal to 1, or you can say it will be 100%. Correct? But in case of weak electrolyte, it will be definitely less than the 1, or you can say alpha value will be less than 100%. Correct? It also depend upon the nature of solvent. Which solvent do you take? Because every solvent will have different nature of solvent, basically telling you the medium. Correct? Medium will decide how easily. Okay. So if dielectric constant is increasing, then alpha will also increase. If dielectric constant increase, then your alpha will also increase. Okay. Example, if you take H2O, here nu value is equal to 81, dielectric constant value. Okay. If you take D2O, which is heavier, then your value is less. If less value, less alpha, less breakdown. More value, more alpha, more breakdown. Okay. Any doubt?
So can you repeat that last part? The H2O is equal to what?
This is just one example. You don't need to remember the data.
Yes, sir. It's
But
not.
if you compare H2O and D2O based on the new value will be given to you. You don't know for every compound what is the new value. What we are trying to convey, if dielectric constant new value increase, then alpha will also increase. Compared to D2O, H2O have more value, high alpha, high breakdown in case of what.
Yes, sir.
Okay. Next, very important concept, common ion effect.
Sir, so for H2 it will be higher, right?
Yes, for
Okay.
H2O it will be higher because more new value.
Yes, sir.
Common ion effect. So in this common ion effect, when we take a strong electrolyte, have a common ion and mix with the weak electrolyte, then degree of dissociation of weak electrolyte will decrease. And that is common ion effect. If you have two, if you have strong electrolyte and you have weak electrolyte, okay, in that case, alpha of weak electrolyte will decrease. That's the ultimate thing. Alpha of weak electrolyte will decrease. Alpha of weak electrolyte will decrease. And this is the common ion effect. Why? Because one ion is common. One ion is
So can you
common.
repeat?
If strong electrolyte and weak electrolyte have common ion,
Yes, sir.
then degree of dissociation of weak electrolyte will decrease. That is the simplest common ion effect. Okay.
Yes, sir.
Example, you know, you have weak electrolyte CH3COOH. So it will break down into CH3, COO negative, and H positive. Now, if you take strong electrolyte of the common ion, example Na, so CH3COO is negative and Na positive. Correct? This is strong electrolyte. This one is weak electrolyte. Weak, strong electrolyte. Okay. In this case, you know CH3CO negative concentration will increase. So H positive concentration will decrease. Correct? From this, if you see CH3CO negative concentration increase, so H positive concentration will decrease. Okay, this is common ion effect. Any doubt? Any doubt, guys?
So can you just repeat the example? Like, can you just explain the example again?
In this common ion effect, you have a common ion CH3CO negative. So if you know you are mixing both of them, your CH3CO negative concentration will increase. So overall, your H positive concentration will decrease, and that is a common ion effect. So
Okay,
if
sir.
H positive ion concentration decrease, your uh, alpha will decrease. Why? You know H positive concentration is equal to C alpha. We did last time. So if
Yes, sir.
H positive decrease, then alpha also decrease. This is common ion effect. Due to one common ion, your
So the concentration of the common ion will increase and the
yes,
weak
but
electrolyte will decrease. That's all right.
yes,
Okay, sir.
okay. Almost like this, you have one more topic, odd ion effect. Odd ion effect. This simply says that if you have a strong electrolyte, have odd ion, and this is mixed with the weak electrolyte, then degree of dissociation of weak electrolyte will increase. Here, alpha of weak electrolyte increase. Okay. This is because of the odd ion. Example, if you have CH3COOH, when you break it down, then it will form CH3COO negative and H positive. If you take NaOH, you know NaOH is a strong electrolyte and CH3COH is a weak electrolyte. Right? So here Na positive and OH negative. Correct? What will happen though you don't have any common ion? But these two ions will combine with each other and they will form water. It will form water. And in this case, water amount will increase. This is due to odd ion effect. You will ask, sir, what is the impact of this water? If water increase, then you know it is dilution. More addition of water, more dilution, and because of dilution, alpha increase. Right? Because of odd ion, your overall water amount increase. That's why it increase.
So can you explain it again? I'm not understanding.
Yes. So you have two things. You have two different. One is strong electrolyte, another is weak electrolyte. They don't have any common ion, but due to odd ion, your H positive and OH negative will combine with each other and it will form water. Formation of more
Yes.
water means dilution. Dilution, and you know alpha inversely proportional to the concentration and directly proportional to the dilution. So more dilution, more
More
alpha.
alpha.
That's what we are saying.
Yes. So does this happen only because of the water? Like
Yes,
every
because of
odd ion effect happens only due to water formation, right?
yes.
Yes, sir.
Anybody have doubt?
No, sir.
So common ion effect and odd ion effect is very basic. In common ion, whenever common ion increase, your H positive decrease, weak electrolyte concentration decrease, so your alpha decrease. But in odd ion, because water increase, more dilution, alpha increase. Done. Okay. So tomorrow we'll do a remaining part, but I'll tell you last basic part of not this chapter, but in general about logarithm. In case of log, you have many basic formula like natural log x will be equal to 2.303 log x. You must have seen this, correct? Natural log x is equal to 2.303 log x. This is also equal to log ex, meaning is same, correct? Second, if you take log as we did in the last topic, log x into y, it will be equal to log x plus log y. And if you take x by y, then it will be log x minus log y. Okay. And last thing, if you have log x raised to power y, whatever is your power will come into multiply. So these formula are really crucial because in this chapter you have acid, pH is calculated like minus log as positive concentration. So you need log. So these formula are very basic about the log. In this case, what is log 1 value? Chandana? 0.
Yes, sir.
Log 2 value? 0.301, just write 0.3. Log 4 value, Chandana?
It's a 0.45.
2 raised to power 2.
It's
So it will be multiplied by
0.60.
log 8 value,
0.8.
2 raised to power 3. Makes sense? So if you know log 2, you can easily calculate log 4 and log 8 because log 4 will become 2 square and log 8 will become log 2 raised to power cube, right? Example here, if you see ki log 3 value, you don't need to remember everything, but this is important, absolutely important. Log 2, log 1 and log 10. Log 10 is equal to 1. Log 10 is equal to 1. Okay, these are important. Example log 3. So it should be between log 2 and log 4 like nearby. So it is like log 4 7, very close to log 0.45. Average of log 2 and 4 is log 0.45. So approximately. So according to this, Pratigya, what should be log 9? Log 3 square, double of this.
Yeah.
Approximately 9.4, 9.5 because it is actually like this. No need to remember log 3 and all. It's just I am telling you how to do comparison. Correct? Log 5 is approximately equal to 0.7. Barinder, what is log 100 value? Jordan, log 10 raised to power 5 value?
It will be 5, sir.
Then opposite to this is antilog. Example, log 1 value is 0. What will be antilog of 0? 1. Ulta of this. If log 0 value is equal to 1, so antilog, no, I wrote ulta. Log 1 value is equal to 0, so antilog 0 value will be equal to 1. Whatever your log is, you can correlate like that. Right? Example, if you take antilog of 0.3, what will be the value? 2. Why? Because log 2 value is equal to 0.3. Correct? So log 10 value is equal to 1. So what will be antilog of 1? 10. Just compare with log and make it ulta. Because this log will go to another side and it will become antilog. Antilog of 1 will be equal to 10. Okay. Example. If you calculate log 6
So
value.
little bit, can you scroll up this one bit? Yes.
If you take log 6 value, can you write 6 into this form? 2 multiply by 3. So it is equal to log 2 plus log 3. Log 2 value 0.3, log 3 value 0.47. You can calculate the value. Correct? Like log 30 value. So you can write log 3 into 10. Log 3 plus log 10. Log 10 value is equal to 1, log 3 is 0.47. Done. Correct? Why we did all this thing? Because we will do pH scale. We'll do pH scale, and in pH scale we need all this. So tell me guys, is this enough for you, or you feel that we can continue? No issue.
So what?
Is it enough for today, or you feel we can do more?
Sir, can you
Yes,
explain the common and
common ion effect.
yeah?
हाँ बिल्कुल. So प्रतिज्ञा कॉमन आयन इफेक्ट में पहला क्राइटेरिया है कि वी हैव स्ट्रॉन्ग इलेक्ट्रोलाइट एंड वीक इलेक्ट्रोलाइट. फर्स्ट. सेकंड, in common ion effect, one ion should be common. Example, in CH3COH, this is weak electrolyte, and there will be one strong electrolyte, any form, like its ionic form. Okay. So CH3COO negative is common ion between them. So if this is common ion, so its concentration will increase. If its concentration increase, CH3CO negative concentration increase, then other thing concentration will decrease, H positive ion concentration decrease, and H and alpha have direct relationship. If H decrease, alpha will decrease. Any doubt?
No, sir.
Hmm. Any other question, guys? Tell me, as of now, see, we need to solve many more questions to get better clarity. As of now, do you really think this chapter is difficult?
No, sir, it's actually easy.
Yeah. So that's why we will solve all the question. Okay. So that's all for this class, guys. See you tomorrow.
So, 1 second, can you show the anti-log part again?
Yes, sure.
So can you send the PDF? I need to write more, like
Yes,
few points.
yes, I'll send this PDF and send me your notes. All of
कल की
you.
timetable.
कल का timetable. कल का timetable.
So my phone is dead. I'll like it's getting charged. I'll send it in like sometime.
Okay.
I've written, yeah, but I'll send it.
Oh. So I will send guys this PDF in the group. You send your notes. And